Hey, I'm D'Artagnan Rian for SMR Vault, and welcome to the Week 6 update for the 2017 build season. So, it's the final week of the season, and teams are wrapping things up and getting ready for Bag and Tag Day. The Hardin Valley Robotics, despite not being able to meet for a while last week due to illness around East Tennessee, made some serious progress on their climber and ball intake. The climber appears to follow a conical design, and at least in practice, they've opted to use a flat rope, which seems to complement their climber design pretty well. Their ball intake is made up of a sweeper mechanism which resembles the design of a broom in the front and a belt system to direct fuel into their robot. Hardin Valley's greatest success of the season was having working prototypes in the first week. They planned to work on their bot, their twin bot, and their pit handout page between Bag and Tag Day and Smoky Mountain Regional, and they expect their forte at the competition will be their strong climber, drive team, and strategy. Week 6 wasn't a week of major aesthetic changes for Blount County Robotics. The only major differences we are seeing are in the shooter intake and the onboard hopper. Essentially, the intake accelerates wiffle balls upwards through the newly added chute and into the hopper, which is composed of plexiglass in between the frame to maximize space for wiffle balls. As far as rope gripping goes, a lot of teams have pursued the idea of hooks being used merely to guide the rope into the climber. Once guided in, the friction of the rope should cause it to wrap around itself, creating a fairly secure grip. BCR experimented with carpentry hooks, but they proved unreliable and ended up bending. The team turned to a more crude yet effective design that incorporated gun magazine springs bent into hooks. The springs proved to be pretty strong, and when they bent, they can be easily reshaped. So again, the theme of volume constraints is still apparent, and this week those constraints drove BCR to create a non-motorized mechanism that allowed the intake to be fit within size constraints up until the beginning of the match. They accomplished this by attaching a threaded head to the outside of the belt system. Once the intake is raised and held in place by the hook, the motor engages and the threaded head rotates the hook off.
Hey guys, we're at Farragut High School right now. As you can see behind me, Farragut has been generous enough to actually build this practice field for teams to come on and practice. Right now, we're gonna go check out some of the teams here. We have the Wolfbots and Farragut team Flagship, and we're gonna see what we can gather and see what kind of progress they made and how their robots are performing.
Set up in Farragut's old automotive space, Flagship's practice field is an incredibly accurate representation of what teams can expect at competition. We caught up with Team 5508, the Wolfbots, and their team captain, Keegan, walked us through some key elements of their bot, which they call Tarzan.
We have a camera so we can find the gear and go up to it. This will open, our gear will come in here. There's a small shaft in here that spins constantly that will automatically align the gear. We have limit switches in, so when this is open to get the gear, the second it comes in, the whole gear grabber assembly will close.
Yeah.
Alright, when we want to drop the gear off, this whole assembly will come up to the upright position. Also, while we're picking up gears, the balls can be dumped in through here. The balls will come into the robot, but they will not be allowed to come out with these bars.
Right. Yeah, I noticed that.
And then when we go to climb, we have our climb assembly right on top. So we're planning on just dropping the rope in. If the rope does not land in, we can drive through the rope and it'll land into here. Once this is in, we have this twine that will be latched all the way around the robot. This will spin the rope, the twine up, strangling the rope. Now, when the balls are on the field and we need to pick them up, on the front of our robot, we have a whole PVC assembly with grip tape. So a ball will come in, this whole system runs off motors, and the balls will be pulled all the way up through the ramp into the robot into this area. We want to drop the balls into the low goal. We will click a button, this whole plate will come down, and on the bottom there's a shaft with teeth that spins and actually forces the balls to come out.
Right.
Yeah.
Yeah, I have.
After a few hours of practice, he got back to us on his concerns, hopes, and plans for improvement.
Okay, so tonight we figured out that our drivetrain has too much power, so we fixed that by reducing the power to about 75% unless it's overridden by a button that allows us full power. We also figured out that our climber, if it's not in the correct direction, will back drive the screw and pull it out and break it. And we also figured out that we need to solve the problem of our belts binding on our ball system to pull in, because they start binding and then the whole ball system will not work.
So what's tomorrow going to look like for y'all?
Tomorrow we should have everything ready to go and run.
Then we just have to put it up and then we're ready.
Yep.
Cool.
We also got to speak to Zachy from Team 3140 Farragut Flagship about his team's strategy throughout the season and going into competition.
So this year, during our strategic analysis, we decided to focus on the gear for the first competition and the qualifiers at the first competition. But if it came out to where, for after the first competition, we found out that shooting might be more in our realm for advancing, we decided that we still wanted to have a decent shooter, but we really wanted to focus really hard on our gear system and getting that to be good and finalized. So that's what we worked on mainly. And then, so that kind of actually messed us up because now we have a pretty good shooter and a really good gear intake and delivery system, but we have some issues with getting all the balls to the shooter. So that's one of our final things to tune on our robot before we bag it. It's making sure that, because we know our shooter can make the shots, it's just about getting the balls to it consistently. So that's one of the things we're really going to work on. So, yeah.
Alright, that's it for the final week. We'd like to give a big shout out to Farragut for setting up such an elaborate field, and a big thanks to Wolfbots, Farragut, Hardin Valley, and BCR for contributing this week. Don't forget to like this video and subscribe to our channel. From SMR Vault, I'm D'Artagnan Ruyan, and keep it nerdy.